Hello everyone, welcome back to Think Lab by Saurabh. So today we are going to understand an important topic in large language model. The topic is the measuring the transformer inference performance. So many people focus only on the training a model, but in the real world application, inference performance is equally important. So inference is the process of using the trained model to generate the prediction or response. So every time you ask, question to chat GPT, so there in the backend, there is inference will happen. So every time Gemini write an answer, inference happen. Every AI chatbot, coding assistant or translation system perform the inference. So the question is, how do you know if our inference system is good? We measure it using the several performance metrics. So let's understand each one step by step. So what is the goal? The main goal is simply to generate the response as quickly as possible and also use less GPU memory and reduce the infrastructure cost, right? So there are several thousand of users simultaneously using that particular model. So maintain high quality response. So that is the main task. We have to maintain the high quality of response. So a production AI system must balance all these factors. So now we are moving to the we check the every one parameters using for inference. So first one is the latency. So let's begin with the latency. So latency means the waiting time experienced by the user. So imagine you ask ChatGPT a question, right? So how do you know? How do you wait before seeing the answer? So that waiting time is called latency. So lower latency it means the better user experience. So latency has a three important measurement. The first one is the we call time to first token. We call TTFT, right? TTFT means time to first token. So it's measured a time from sending the prompt until the first generated token appears, right? So we have to check the user always check the TTFT immediately, right? So if the first token appears quickly, the application feel very responsive, right? So if even if the full answer take longer, so user feel the system is fast, right? So TTFT depend on the several factor. First one is the prompt processing. Second one is the attention computation. After that, we have to check the KV cache creations, GPU scheduling and the network delay. So lower TTFT always better. So then we have to check the time per output token, we generally call TPOT. So after the first token appears, the model continuing generating the new token, right? So this is the continuation. First, the first token will appear, and after that, the continuing generating the new tokens. So TPOT measures the average time required for each new tokens. So if TPOT is low, words appear smoothly. So and also streaming feel neutral. If the TPOT is high, so response appears slowly and user notice delay between the words. So lower TPOT improve the user experience, right? So now we are checking the another point, end-to-end latency. So this is a total response time. If you start when the user send the request and it end when the complete it the generated, right? So most applications lower, if most application lower end to end latency is the final objective, right? So now we are moving to the point number two is the throughput. So now let's understand the what is the throughput. So throughput measure how much work the system completes, right? So instead of measuring one user, throughput measure the entire server. So typically in the throughput measurement, there are several parameters we include. First one is the token per second, request per second, and the sample per second. Suppose one server process 5 requests, 500 requests per minute. So another server process, 1000 requests per minute. So the second server has the highest throughput, right? First server are sending the 500 requests per minute. Another server process 1000 requests per minute. So in this scenario, the second server has the higher throughput. So higher throughput means the better scalability, right? So large AI company optimize the throughput to reduce the server cost. The third one is the memory usage. So next came to memory usage. So transformer model consume large amount of GPU memory. So memory is used for several purposes. like model weight, intermediate activations, KV cache, temporary computation. So among these KV cache, becomes the extremely important for long conversation. So as the context, as the context that increase, KV cache also increase. So more memory means the fewer user can be served simultaneously, right? So efficient memory management reduce the infrastructure cost. So point number four is the GPU performance, right? So GPU performance, GPU perform billions of mathematical operation every second. So however, a powerful GPU doesn't guarantee fast inference. So we must keep the GPU busy. So important GPU metrics include, there are several parameters there, but important GPU metrics include the GPU utilizations, memory utilization, tensor core utilization. So if the GPU utilization, if the GPU utilization is only 30%, so most hardware is sitting idle, right? So good inference system keep the GPU utilization very high. So this improve the efficiency, right? So now we are moving to the point number five, inference optimization technique. So now let's discuss the optimizations, right? So optimization means the making inference faster without significant reduce the quality. So what is the quantization, right? So quantization, it means quantization convert large numerical value into the smaller format. For example, if you are taking the FP3 32, right? So we have to also convert to FP16, right? So for the there is lots of benefit for quantizations, right? Like they can also they use the lower memory, they can perform the faster computation, even the lower cost, right? So important thing is the flash attention. So flat attention is the optimized attention algorithm, so it reduces the unnecessary memory movement. So it's also speed up the attention computation. So this is especially useful for the long prompt, right? And KV cache, now we are discussing about the KV cache. So during the text generation, so model repeated in the repeated way, they use the previous attention value. So instead of calculating them again, KV cache store them, and this save the computations. So generation become much faster, right? So also important is the continuous batching. So normally the server wait for the batch to fill. So continuous batching keep the adding new requests, in a dynamic way. So they use the CPU means remain busy, right? This improve the throughput, and it also reduce the time. No, it's also reduce the idle time, right? So now we are moving to the, like a performance score, right? Now we are moving to performance scorecard. So when you are going to perform the evolution of a particular inference system, so remember these three rules, right? Remember these particular rules. Lower TTFT is better, lower TPOT is better, lower latency is better, lower memory use is better, lower serving cost is better, higher throughput is better. So higher GPU utilization is better, higher accuracy is better. So never optimize only one matrix, always maintain a balance, right? Now we are going to compare with the real world example. So imagine there is two chatbot. Chatbot A gives the first response in 1 second. Chatbot B gives the first response in 4 seconds. So user naturally prefer chatbot A. So now imagine another server. If the server if the servers only 10 users simultaneously, and the different servers serve 1000 users simultaneously at a time, so the second server has much more higher throughput. So this why company optimize the inference performance. So why this matters? So every AI company measure the inference performance, like OpenAI, Google DeepMind, Anthropic, Meta, Microsoft, Nvidia, Amazon. So all the production AI system continuously monitoring the latency, throughput, GPU utilization, memory cost, and without optimization, serving millions of users become extremely expensive, right? So now we are going to summarize this video, and the final takeaway is, so inference performance is a just an important model accuracy. So a successful AI application should be low latency, high performance, high throughput, efficient memory uses, high GPU utilizations, lower infrastructure costs, high quality of output. When all these metrics are balanced, so we get a fast, scalable production ready AI system. So thank you for watching. If you learned something new today, so please like the videos, share with your friend, and subscribe the Think Lab by Saurabh. So see you in the next video. Thank you. Happy learning.